Hi, this is going to be a work through for the first worksheet of the OChem workshops. So starting with number one, this is asking us to count the number of hydrogens and carbons in each structure. And we have the molecules in a line bond structure. Line bond structures implies the carbons and hydrogens. So each bend in a molecule counts as one carbon, as well as one terminus for one carbon as well. So if we count 1, 2, 3, 4, 5, 6, 7, 8 carbons, and we know that carbon likes to have 4 bonds, so we can see here that we have one bond with this one carbon. So the other 3 must be bonded to 3 hydrogens. Okay. This one is bonded to 1, 2, 3 other atoms. And so this carbon must have one other implied bond to hydrogen. So if we do the rest, let's see, CH3, CH3, we can see that there's going to be 3, 6, 9, 12, 15, 16 carbons, hydrogens, 16 hydrogens, as well as one other hydrogen right here, making it 17 hydrogens. This third one, again, each bend and terminus counts as one carbon, with the other bonds implied as a hydrogen. So this carbon has 1, 2, 3 bonds and needs one more to complete its octet. And so we imply that another hydrogen is right there, counting it as one hydrogen with one carbon. If we do that on the rest of these carbons here, then we have 3. This one has 1, 2, 3, 4 hydrogens. 4 bonds. 2 of them are hydrogens. This carbon has 1, 2, 3, 4. 4 bonds to that carbon, meaning no hydrogens there. And 1, 2, 3, 4 bonds to that carbon right there, meaning no hydrogens. This carbon is bonded to 1 and 2, meaning the rest of the other bond goes to 2 hydrogens. So we have 1, 2, 3, 4, 5, 6 carbons, plus another one, 7 carbons. And then we have 1, 2, 3, 4, 5, 6, 7. Don't forget the hydrogens on this amine, 8, 9 hydrogens. All right. And for this walkthrough, I'm only going to do a few problems from each question. The rest of the problems that I don't cover is up to your practice outside of class and outside of workshop times. So, number 2, it says to provide the IUPAC name for the compound below. Let's start off with the first one. So how do we even go about naming these alkyl chains? Well, we have to make some rules. Number 1, always count the longest chain. So here we can count 1, 2, 3, 4, 5, 6, but we seem to know that there is a much longer chain than 6 carbons. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9. But what's the difference between how I counted just now versus 1, 2, 3, 4, 5, 6, 7, 8, 9? The difference is that this way of counting grabs a substituent first, and going 1, 2, 3, 4, 5. The other way. You can think of it like a game of cards. You can count, or you can observe that you can start here, and then you can say like, oh, I'm bonded to another carbon. What else are you bonded to? I'm just bonded to a methyl, and I'm also bonded to another carbon. The carbon that's bonded to the substituent always wins that game. And we can see another example in a little bit. For right now, we count the chain in a way that the substituents are always on the lowest number. Since we have a 9-carbon chain, that is a no name. And we have a methyl at carbon 2 and carbon 5. All right, and since we have 2 methyls, we have a dimethyl. And to put this together, we go for the 2,5-dimethyl, no name. We can see that the comma here separates numbers, while this dash here separates numbers and letters. All right, so sometimes I see that people put a little dash between the substituent name and the parent name, but there's no need for that because dashes separate numbers and letters, not letters and letters. But what if we have a cyclic chain, a cyclic compound? Let's go for these one right here. Since we have a cyclic ring, that means that we are going to use this suffix, cyclo, means ring. Now we have a 5-membered ring. Now we use a cyclopentane as our parent. And so how do we count along the ring? 1, 2, 3, 4, 5, or the other way around, or we can start it at any other. But our first rule was to count the longest chain. You may wonder, why can't I count 1, 2, 3, 4, 5, 6? Well, if I count it that way, there's no way for me to actually name this part. So we have to note whether the ring is the longest chain or the alkyl chain is the longest. So we only see 1, 2, 3, or 1, 2, and we can only see 1, 2. That being said, the ring here in this example is going to be the longest chain. How much time do we have? 122. Okay. So again, I can count this way or that way, but where do I start? Well, take note of the substituents we have. We have an isopropyl, and we have 2 methyls, making it a dimethyl. When you count along a ring, or even a chain, you should start counting alphabetically using the suffix. So we're going to count this way, so that we start at the dimethyl, and then our isopropyl is at a lower number. So 1, 2, 3, 4, 5, and not 1, 2, 3, 4. So the isopropyl will be at 4. We want isopropyl at 3 because it wants the lowest number for our substituents. So, with that in mind, we're going to do 3. Oh, I'm sorry, I forgot to mention. We alphabetize, or we count the D in dimethyl when we number our chain, but we do not alphabetize using that suffix. Instead, what we're going to use is the M in methyl when we alphabetize our name. So our answer would be 3-isopropyl, 2 because there's, oh, I'm sorry, 1 because there's 2 methyls at once, so we have to note 1. And then dash dimethyl cyclopentane. Okay, we can see that the 3 tells us that there's an isopropyl at the 3rd carbon, and there's a dimethyl, 2 methyls at carbon 1. And then cyclo, because there's a ring, and a pentane, because that ring has 5 members. Okay, so our general kind of formula to name is going to be our number dash substituent plus our parent name. Our parent name being cyclopentane, our substituent being dimethyl. We have more than 1. And number to signify which carbon has that substituent. Okay. But what if we have a ring and it's not the longest chain, or it's not the longest member in that chain? So we're going to look at another example where that is so. We're going to look at this one. You can definitely see that the longest chain is not this ring here. We can see that there's 1, 2, 3, 4, 5, 6, 7. Why don't I count the other way? 1, 2, 3, 4, 5, 6, 7. Because when I count, let's put our fingers. Carbon, carbon, but there's no substituent here, but there is one right here. So this one wins. It's like a game of cards. Like, what do you have? Okay, so if we count 1, 2, 3, 4, 5, 6, 7, that makes it a heptane. All right, heptane. And we have a methyl here and a methyl there. Dimethyl at 2 and 5. Let's just do methyl at 2 and 5. That was a dimethyl. And what do we even do with this huge thing right here? Well, this is actually going to be its own substituent. We're going to call it a cyclohexyl. Cyclo because it's a ring, hex because it's a 6-membered ring, and il because it's a substituent, like an alkyl, but instead of alkyl, it's going to be a cycloalkyl. Alkyl meaning it's made of carbon. Right? Okay. So now that we have the information we need to bring about a name, we have our parent name, we have our substituents, as well as the number where it is, and yep. So all we have to do is alphabetize. right? So 4 cyclohexane, 2 5 dimethyl heptane. We count the longest chain. We count so that the substituents are on the lowest number. We identify our substituents, and then we use this formula to make our name. Very simple. And the other ones you can do on your own time for practice. Okay. All right. How much time do I got? Oh, that's my break. Bye-bye.